In this video, we will continue looking at apportionment, this time with the Huntington Hill method. Pictured below the title are Huntington and Hill. For more information, look at the Canvas page. We're going to focus on the technique, and this is the technique, the Huntington Hill technique, that is currently used, when I say currently, 2023, in the U.S. Congress to apportion. Steps 1 and 2 are going to look very familiar. We're going to find the divisor the way we have before, total population divided by the number of seats. Number 2, find the quota for each state by dividing the state population by the standard divisor from step 1. Something new in number 3 here, right? Cut off the decimal part to obtain the lower quota. Now that's the same as before, but we're going to call that in. For example, if our quota is 12.215, we would cut off the decimals and call it 12. And then in would become 12. Then we're going to compute something, and I'm going to write the formula right now. We're going to compute the square root of in, right? That's the lower quota minus the decimals times n plus 1. All right. This will be called the geometric mean. So for example, if our lower quota was 12.218 and we call n 12, we would be calculating 12 times 12 plus 1, which is 13, and then take the square root of that. Step 4, what we're going to do is compare the geometric mean from step 3 with the quota in step 2. If the quota is larger, we're going to go round up the quota to include one more seat. If the quota is smaller than the geometric mean, we're going to round down to not include an extra seat. What might happen, in our first example, you'll see this, is we might be done at this point, right? We might have exactly allocated the correct number of seats. But if not, and you'll see this in our second example, there is a possible step 5 where, like previous methods we've looked at, you might need to adjust the divisor. All right, we'll look at that in our second example. For now, let's take a look at our first example. This is one we've done before about the Bandana Republic. Remember, there's 4 states, and we're trying to give out or apportion 160 seats. In this example, the total population is 8 million. I'm trying to include the directions there below, right? There's the directions for comparing. And so we're going to start the same way. We're going to get the divisor by taking the total population, which is 8 million, right? We're going to divide by the 160 seats, and that gives us a divisor of 50,000. Then we're going to figure out the quota for each state by taking the state population and dividing by the divisor. So the first one is 66.2. Now I'm going to do something here which will be helpful later. If it comes out to be an even decimal like this, I make it a practice to always write 3 decimal places. So if it's 0.2, I would add 2 extra zeros and just call it 0.200. Okay, next one, 2,670,000 divided by the divisor, and that one's going to be 53.4. And I'm once again going to add 2 zeros to that. You'll see why later as we compare. The next one is 26.6, again adding 2 extra zeros. And the last one is 13.8, but again adding 2 extra zeros. Now the lower quota will be, again, rounding down. So we're going to call that 66, 53, 26, and 13. This is where we're going to do this new step, calculate the geometric mean. That is n is our lower quota, times n plus 1, and then we'll take the square root of that. I'll write down the first state for a puree. We're going to take 66, that's their lower quota, multiply that by 1 more, 67, and then take the square root of that. Now I'll use a calculator here from the computer and show you some of the pitfalls of that, all right? Some of the pitfalls that can happen from using this calculator is that you have to do it from the inside out. So what you would do first, if you use this kind of calculator or a cell phone calculator, is type 66 times 67. Hit equals first, get a pretty big number, 4,422, and then hit the square root key. Right, and you can see it's a big decimal, but just take the first 3 decimal places, round it off. 66.498 is what I will write in here. Okay, so let's see, 66.498. All right, you'll do that for each of the rows. Let's go ahead and do the comparison, though. So the comparison is if the quota is larger than the geometric mean, then round up. If it's smaller, round down. Now, if we look up here, our quota has a decimal of 0.200, but our mean has 0.498. That means our quota is smaller. So if it's smaller, round down. 66.2 rounded down to 66 as the final apportionment. And then we're basically going to do that for each line. So let's take these geometric means. Let me scoot this calculator over. All right, for the next one, it's going to be 53 times one more, 54 equals that. Take the square root, 53.498. All right, 53.498. And once again, when you compare, you can see 400 is smaller than 498, so round down to 53. All right, next one, our lower quota is 26, so 26 times 27, and then take the square root of that, 26.495. All right, 26.495. This time, though, the quota of 600, the decimal part, is bigger than 495. Remember, if the quota is larger, you're going to round up. So we're going to go from 26.6 up to 27. All right, last one, take 13 times 14 and take the square root. It's 13.491. All right. Now maybe you can see why I've written 3 decimal places. It's easier to compare. So 491 versus 800. 800 is larger. The quota is larger. So once again, when it's larger, right, we're going to round up. We're going to round from 13 up to 14. Now at this point, you might be done, you might not. But what you do is you add up all of the apportionment, 66 plus 53 plus 27 plus 14, and I get 160 seeds. Yay, we are done. All right, because that's exactly the number of seeds we wanted to give out. If that number did not match, we would need to go on to adjust the divisor, as you will see in our next example. That will be it for this video. We'll take a look at a different example in our next video.